In this demo, we'll showcase some Kinetica native data science capabilities and illustrate how a federal organization could leverage Kinetica as a platform for various types of cybersecurity preventative measures. And to do that, I'm going to leverage the Canadian Institute for Cybersecurity. This is an awesome public resource that has a wide range of cybersecurity attack data. And specifically, I'm going to use the IDS 2018 training set and focus on botnet detection. So the first step is actually ingesting this training data into Kinetica. Here I have a table that's a little over 3 million records. And using our Spark connector, I was able to ingest this in a few seconds. And at this point, I am ready to begin model exploration and development. So I have a pretty cool toolkit for that, these pre-configured Jupyter notebooks. And these notebooks come pre-installed with all of the most popular data science libraries. So we can take a look at that. And this includes everything from pandas, NumPy, scikit-learn, TensorFlow, Keras, PyTorch, CML, CDF, and so on. And this environment is multi-tenant, so if there's a library that you would like to use that's not already included, it's very simple to actually install that into your environment, and you don't have to worry about that conflicting with other users. Another cool piece is that these pre-configured notebooks have direct table access to Kinetica, so I can point to the table name, the IP address of the database, and then provide the database credentials. And I now have direct table access where I can hydrate a data frame directly. And then again, at this point, I would begin feature analysis and model exploration. But for the sake of time, I actually really want to focus on that path to production. So this is the point at which we've developed a model, the metrics check out and look good, and I'm ready to actually put this into a production workload at enterprise grade scale. So key concept here is that we are using Docker and Kubernetes. So big thing is that we're going to containerize that pre-trained model. And what that means is we are agnostic to the language or library that was used in developing the model. So whether the user wants to use Spark ML, scikit-learn, TensorFlow, so on, it's very simple to actually containerize that entire environment and then using our SDK, pull it from Docker and launch it on Kubernetes. And that's pretty industry standard right now. The idea is that we've just made this incredibly user-friendly and push button. You don't have to worry about the hooks and wires. We manage and orchestrate that for you. And again, another big thing with that is you don't need to be a Kubernetes expert to leverage this technology. So at the time of install of Kinetica, you have the option of selecting the Active Analytics Workbench package. And that's Kinetica's platform for data science, and it runs on top of Kubernetes. So at the time of install, we can automatically stand up a Kubernetes cluster for the user. And that's again, completely behind the scenes and automated. Or if the customer has an existing Kubernetes cluster, that's simple to bring their config file to Kinetica as well. And we'll install the Active Analytics Workbench on top of that. Now, when we want to launch this model on Kubernetes, it's a pretty straightforward process. We point to the Docker URL. So that again is the URL that has the container where I publish my pre-trained model. We point to the module and the function. So this is, in this case, I developed this model using Python. So this is the Python file that houses the function in that file that will be receiving data from the Active Analytics Workbench, calling on the pre-trained model to make the inference, and then returning those results to the Active Analytics Workbench. So the input columns, this is my feature set. I'm using everything from packets with at least 1 byte of TCP data payload in the forward direction. I'm using a number of packets with RST. I'm using a number of packets with ACK, mean size of packet in the backwards direction, so on. This is very specific features, obviously, to network parameters that we're going to use to classify whether a network detection is either a botnet or if it's benign. And a key thing to remember here is that this model is going to be expecting our input column to be in dictionary format. So that'll look like RST flag count 5, for example. And then as well as the output column, that will be expected to be returned to Kinetica in dictionary format. So again, intrusions, and then botnet or benign, for example. Now we can go ahead and create this model, And the deployment is entirely push button. So we can name the deployment. I want to deploy this in continuous mode. I actually used a random forest classifier for my botnet detection. And again, I want to deploy this in continuous mode. So how we do that, we point to the source table that'll be streaming these network detections into. So every time a new network detection hits the Kinetica table, this model will be deployed continuously against that table, make the inference, and then store the results in an output table. And that's all automated. So I just name an output table. And I go ahead and deploy. So again, behind the scenes here, we're using our SDK to pull the container from Docker, launch it on Kubernetes, and this entire orchestration is completely automated and managed by Kinetica. Now, as you can see, once this is deployed, we have a full audit log here. So this was built out of a demand in the industry for higher transparency, higher governance, and then also to create a very repeatable and traceable process. So these results actually are going to be stored in a table in Kinetica, just like any other Kinetica table. So you have the inference ID, the receive date, the start date, the end date, if it was a success or not. So if it was not a success, again, you'll have full error log and error stack reporting. And then you have your feature set that we use to classify these network detections, and you have the results. So whether that network detection was benign or a botnet. And this is very useful because now we can leverage this result table just like any other table in Kinetica and query against that. So we can rip out those detections that were botnets and then push that out as a Kafka topic to a downstream application where the government can do what they wish with these network detections that were classified as a botnet. So that's kind of a quick start to end look at how we can leverage Kinetica for streaming ingest of high volume network data, deploy a machine learning model continuously against that incoming data, and make classifications on whether those network detections were malicious or benign, and then push those out quickly to a downstream application.